Okay, hello everyone. Okay, now this is the additional video for derivative part. Okay, we know that uh, in power rule we have a definitions. For example, if f of x is x with power of n, we will have this derivative, right? Okay, now let's see what we can do with the if we have limit. The limit definition, let me write here. This is definition of derivative with limit. So let me write this down first. Okay, now we start with we are using the f of x is x with power of n. Okay, now we can write limit, and then we start to plug in our functions. So this will be x plus h with the power of n, and this is minus x with the power of n. Okay, now how do we solve these equations? Okay, now the idea is, imagine that this is some a with the power of n, and this will be b with the power of n. So we will have a n minus b with power of n. Okay, now remember, if you have this terms here, a squared minus b squared, we can make some factorizations, right? And let's increase this, becoming 3, becoming cube, like that. And we are just factorize the a minus b. This will be a squared plus a b plus b squared. Okay, and start another one. Let's say 4. Can we doing this? We still can, I think. Let's start slowly. A cube. This will be a squared b, right? And then ab squared, right? And then b cubed. And eventually you can do all the number here, but eventually you will reach some n. Okay, so we can have an n here, so a number n, and we still can factorize and look at what we have done here. The first one is a1 b1, like that, with the power of 1. We have the second one. I think it's more clear if you see the second one and the third one here. We can see that this is 2, this is 1 1, right? And then 2. Okay, and this is 3 2 1 1 2, and then 3. So let's look here, and if we can imagine, okay, if this is n minus 1 from this 3 here, this will be n minus 2, and this will be just b. And then if this is n minus 2, this is n minus 1, right? So we may have a and plus, and maybe another term that maybe you will have like a and 3 blah 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 blah, right? You can have more and more terms there, and eventually you will reach that a and then b n minus 2 plus b n minus 1. So there's a lot of components here, some n. Okay, or maybe just writing that like that. Okay, now by doing so, okay, by doing so, with A is x plus h and B is just x, we can write the limit as h approaching 0 for x plus h with the power of n divided by h. This will be limit as h approaching 0, and we will have probably a long line here. This is divided by h, and we will have, this will be x plus h minus x, okay, based on a minus b there, okay. And then we will have x plus h, and then n minus 1, and then plus x plus h, n minus 2, and then x. Let me make it to the left and make it a little bit smaller. Okay, probably as small like that. And let me go through there. Okay. Now we will have plus some components here, maybe a lot of components there, and plus x plus h, and then x n minus 2 plus x n minus 1. Okay, now from here x is cancelled with this one, so we can cancel the h that is down here with this. So at least, okay, we are not to worry that it will have some 1/0 situations, right? So because we already removed this h here, now we can see from the function here, the equations will be, when we are going to put in 0 to each h here, so let's say this is 0, this is 0, so it will be x, x, and then this will be 0, right? Okay, so for this one, what will happen? So this will be x n minus 2x, so it will be x n minus 1, right? And this will be also similar, so x and then x n minus 2. What will happen? This is also x n minus 1. So we will have, okay, at the end, we will have x n minus 1 plus x n minus 1, and there will be a lot of x n minus 1. And how many that x with the power of n minus 1? This will be n times. So we can make a calculation or make a conclusion that the f prime x will be equal with n x n minus 1. So this is to prove that if f of x is x with the power of n, then f prime x will be n x with the power of n minus 1. Okay, another form to check whether this is true or not, we can also check with the other form. Let's say we have this. And then we can also check when it is x with the power of n. We can also use this and try similar idea. And I think this probably better. Okay, so you will have x n minus 1 plus x n minus 2a plus plus x a n minus 2 plus a n minus 1. Okay, it's similar. And then eventually it actually this step is the same as when you have a and bn from the previous proof, and then you will have the x minus a factorized outside, and then you will have cancellations between this one and this one. So you notice that there is no denominator here. So we can plug in here, and it is actually xn minus 1 plus xn minus 1 plus xn minus 1, right? And n times here, which means this is also similar with the xn minus 1 like that. Oh, sorry. I think this should be A. So it should be A. Because the question is x approaching A. So this should be A. Okay. So f prime A. Okay, I think that is a video that probably helping you to get the concept on how we are proving the theorem. Your textbook is also using the binomial theorem to prove the concept, but I don't think we really need that. So if you want, you can check with the use binomial theorem if you want. I rarely use the binomial theorem because it doesn't widely use. So yeah, you can check out. Okay, but I think with this theorem here, with this limit definition, we already take some proof. Okay, I think that it will be the end of the